Hi, and welcome to PolyWise, our first PolyWise webinar. My name is Tsang. I'm the PolyWorks training manager here at 3D Scanners UK. And today I'm going to show you how we can create a complete inspection program offline. Typically, when you create an inspection program, you can bring in the CAD model, you can create your measurement tools, even set up the measurement parameters to say exactly how you wish to measure the part, be it probing or extracting from scan data. However, typically that's as far as you can get. You can't apply your color maps, you can't apply your alignments until you actually have any data in there. To a certain degree, you can create your report items, so you can take snapshots, create tables, but obviously if you wanted to create the snapshots that contain the scan data in there, even if you then eventually bring the scans in or scan the part, they won't be present when you actually in the reports because they weren't present when you took the snapshots. So typically you'd wait until you have everything available to you before you do the reporting. And that's where the offline simulation mode comes in. It allows you to generate made up data, pretend to connect to your hardware, generate data so you can then apply those color maps and alignments to complete the inspection program. This is great in a situation where, say, for example, you don't have the hardware available yet, it's still being set up, or maybe you are waiting for the part to arrive, or maybe it's still being manufactured. Or better yet, another completely different scenario is you've got a kind of PolyWorks champion who knows PolyWorks inside and out. He can then be creating the inspection programs in its full entirety before then handing it over to the inspectors on the shop floor who don't need to know PolyWorks inside and out. They just need to know how to simply launch the program, play the new piece, and physically measure the parts, allowing for a more kind of streamlined, fluid process. But before I show you that, feel free to kind of use the chat functionality. If you might not be able to see it if you're in the full screen mode. So back at the full screen, use the chat functionality. If you've got any questions, feel free to use the Q&A section as well, and I'll try and answer those towards the end of the stream. Otherwise, let's crack on. So I've got PolyWorks launched here. We're currently in the workspace manager, and I'm going to start a brand new workspace. So first thing I'm going to do is go ahead and save as, and I'm going to save this onto my desktop and call it my offline program. And then I'm going to start a blank brand new inspection. Once that loads in, we're going to run through the process like you normally would with any inspection process. So obviously the first thing we want to do in this example is potentially bring in the CAD model. So I'm going to import the CAD of this 3D Scanners test piece. And the first thing I want to do here is set up our features, more specifically the datums first. So in this case, I'm going to jump into my Create Features tool, create my features, make sure I set up my datum label, and let's start off with datum plane A, for example. Let's use datum B as our cylinder, and datum C can be our top center circle there. While I'm here, I might as well go ahead and create the rest of our measurements as well. So we're going to create the rest of our circles that need to be inspected. Maybe a couple of these cylinders, and I'll even create a couple of these planes here. So maybe side plane, top plane, a plane either side, and these remaining planes here as well. So those are our features created. The inspection also requires us to measure some comparison points. So I'm going to jump into my comparison point tool, create some just standard surface comparison points. I'm going to go ahead and just anchor these across my part. Okay, so I'm just going to dot these around. Obviously, if you have a more specific position to place these, if they're specified in the drawings, then obviously create them hopefully either numerically, or you can import them in from a text file. But in this case, I'm just going to anchor them freestyle. We've got obviously a couple of plane features here, so what we could also include is some distances and angles if necessary. So say for example I'm interested in measuring the distance between these two circles here, for example. I can jump into my feature tool, click on my distance tool, and I can click my two features. Oops, try again, there we go. And I'm only interested in the X value here, so I'm going to drag the text straight down, so I'm only viewing the X value. Maybe I want the distance between this plane and the back plane here. Again, I'm only interested in one dimension here, which is going to be the Z value. So as long as I'm viewing it normal to it, you can see I can have my Z, but I also could have the Y if necessary. And let's also create a couple of angles. So jump into my angle tool. I'm going to create an angle between the top plane, side plane. If I turn this into my Z view, I can see this a little more clearly, that I can actually position my angle, determine which angle I'm referring to. In this case, it'll just still be 90 degrees regardless. But if I also do the same between this plane and this plane here, you can see I can either have my kind of acute angle or my opposite angle. Okay. I can also do one more distance, for example, between this side of the plane and this side of the plane. And again, I'm only interested in one dimension here, which is going to be the X value. So if I straighten the view up, I can just move my mouse straight up to get my X value there. Let's also add some extra measurements just in case, so maybe some calipers perhaps. Obviously we've got this distance here between this side plane and this side plane here, giving us a 35mm value there. We could have done exactly the same between the front of the kind of box section, front and back, but alternatively we could use calipers to achieve that as well. So I'm going to use a single axis type, and I'm going to anchor a caliper from the front to the back, and we've got our distance there. And obviously the difference between this and measuring the distance between two planes is this is actually measuring a pinpoint location, actually between that point there and that point there, rather than the average of that area, and measuring a distance between, to the average of that area. This obviously allows us to potentially pinpoint more calipers there if we needed to, so we can see if there's any kind of variance across the area there. Okay. Actually, let me just create another caliper as well. Another thing we can do is have offset calipers. So let's go ahead and just add kind of a step between those two surfaces, and maybe a step between those two surfaces. So that we have a variety of measurements there. All this can be done as normal anyway, including the next step, which would be to actually tell PolyWorks how we're going to measure this, whether we're going to probe them or extract from scan data. In this example, what we'll do is we'll actually probe our first three features, our datums, so we can get the kind of most accurate results from them as possible, which will then allow us to do an alignment and then scan the part, and we can extract all the rest of our measurements there. So if I jump into the properties of my plane, jump into the measurement tab, and we can tell PolyWorks how we want to extract this, i.e. how to measure this, sorry. So in this case, probe it rather than extract. And the beauty of this is I can actually tell PolyWorks how many points I'm going to probe. So I actually want the operator to probe 8 points every time. I can add guiding instructions if need be it just a message along the top or an actual image pop up on screen to show them where they should be probing. I could even take it a step further again and add in digital targets so they can see actual points on the model to be probing, but that's a lot more advanced, and we can cover that in a future video. That's pretty much it for the plane. I can jump into my next feature here, and that's only possible because I'm in one feature at a time. So again, my datum cylinder B would be probed as well. Rather than using a standard sub method where you simply probe kind of around and up a cylinder, or up and around is up to you, the issue with that sometimes is if the diameter of the cylinder and the height of the cylinder is very similar and you don't probe enough points, i.e. if you probe kind of the minimum amount of points, i.e. 6 points, then there's a good chance that the cylinder will not fit correctly, and it may kind of fall on its side because it can technically fit in different orientations. So to get away from that, to make sure that we do have the cylinder in the correct orientation, I'm actually going to change the sub method here from standard to use initial circles. We know this is an internal cylinder, so we can tell PolyWorks to compensate internally, saving us the hassle of remembering to move to the center, or to take a compensation point, or to make sure that we're pointing in the right direction every time. So this negates any issues there. And again, I'll fix the number of points. And when using the initial circles, you have to probe at least 3 points. So you have to probe 3 points on one end, 3 points at the other end, and it generates a cylinder from those two circles you've probed, hence the name initial circles. If you want to take more points than that, it still has to be 3 points on one end, 3 points on the other, and then you can then add in as many points anywhere in between. It's up to you. So in this case, we're going to increase the number of points to say 9 points. So we'll have to have 3 on one end, 3 at the other, and then how the remaining 3 can go anywhere you like. It doesn't actually matter which way round you start. You can go from left to right, right to left. It doesn't actually matter. Again, we can specify some guiding instructions either by text or an image. But we'll apply that for the time being, and then next. And last of all, we'll have a datum circle C at the top. And again, we'll probe this. We do want to constrain the circle to a plane. And rather than probing the local plane, we've already probed this face here. So let's go ahead and just constrain that to our datum A plane. Obviously, if you aren't too sure if this face is completely flush, if you're worried that there might be any defects on that surface, then it might be worth probing a local plane around the hole instead. But you know, if this is a machine part, you can happily assume that machine face is a clean face. We can just constrain it to that datum A plane. Again, this is an internal hole, and let's fix the number of points. Let's say, I don't know, 5 points, for example. So apply and then close. The rest of our features can be extracted from the scan data, and in this example I'm just going to leave the default extraction parameters to extract all the measurements with. They should be fine, but obviously if there's any problems with them, we can always jump back into the properties and fine-tune them afterwards. Obviously the distances will update and measure once the features have measured. The comparison points will all be extracted as well. The default extraction parameters, again, for those are perfectly fine, and the same applies to the calipers. So all those can be left as they are, ready to extract. So again, this is pretty much as far as you can get normally with a typical inspection process. Without, like I said, any data in there, without probing or scanning the part, you won't be able to actually apply your color maps, perform your alignments, and again, you're limited to what you can do with the reporting side. So this is where things change. If I now go ahead and show you this tool here, this is what we call the offline simulation mode. If I go ahead and click on that, you'll notice I get a watermark on screen stating obviously we're generating simulated data. Just a note, when you take snapshots, that will also appear in the snapshot as well, but only when there is simulated data. As soon as you actually start measuring this for real, that simulated watermark won't be there anymore. And because we've now connected to, we turned on the offline simulation mode, we can now connect to our hardware without any issues or any warnings. So because we're probing and scanning this, let's go ahead and connect to our probe first. As an example, let's go ahead and connect, for example, to a firearm to probe our features with. And you'll notice if I go ahead and connect to the device now, it connects. It doesn't actually give me any error messages, any warnings saying there's no firearm detected and so forth. Obviously, I don't get an actual digital readout value in there because it doesn't know if I'm moving the arm or not because it's made up. But with that, it does then allow me to actually start measuring my features. So if I go ahead and highlight my first 3 features, i.e. my datums, I can right click on those and I can tell PolyWorks to simply probe measured. All the parameters are set up, ready for me to start probing. So when I go ahead and hit probe, it will then run through and start probing each of those features for me with the specified number of points that I've told it. So that is now measured. You can see our rulers with our green and white colors to say that there are dimensional information being reported. And just to show you, if I go ahead and hide the CAD out of the way, hide the features out of the way, increase the size of my points, you can see these points that I have hopefully created. That you can see hopefully showing us the points that it's used to measure our feature width. Okay, now obviously this only works if you actually have a reference, namely, more specifically, I think it has to be a CAD model, I believe, in order for this to work. Without any actual CAD, you won't be able to simulate this because it won't know where to position or make up these points. And obviously, because we're technically creating the data, all the values here are pretty much bang on zero there. Now that we have our features created, again, I forgot a step actually. We could have actually set up our kind of tolerances, dimensional controls, GD&T controls beforehand. We can do that now as well, not a problem. So if I actually go into my geometry control window, you can see I have my circles currently reporting diameter, XYZ positions. If I weren't happy with the tolerances, I can modify those if I wanted to. And this obviously can be done without any data being present. So if I highlight those controls, I can actually modify them all at once. Pick a tolerance template or actually type in my own tolerances in this situation. Let's just type them in, say plus or minus 0.3. Just making this up really. We have our cylinders, we have our diameter in there. Let's again drop that to say plus or minus 0.3. Let's go ahead and apply some GD&T to this as well. So maybe for circle 1, let's add a positional control. So add GD&T position to datums A, B, and C. Obviously apply any kind of material modifiers if necessary. Specify your tolerance. Again, either type it in or pick from your tolerance template. Under say 0.5 for example. And we have our position there. Let's go over to say this plane here, plane 6. Let's add, for example, I don't know, parallelism to datum A with your tolerance, and so forth. Same with your comparison points. You can set up the tolerances, tweak those if necessary. Same with the calipers. We can change the tolerances of those as well. So again, just click on the drop-down arrow next to your tolerance if you want to, or click on the spanner icon there. In certain situations, you are given obviously not only the upper lower tolerance, but upper lower warnings as well. So you've got this kind of two-stage tolerance going on. Change those if you want, and all those tolerances are applied to those calipers. So all that can be done without any actual scan data in there. However, we're now ready to apply the alignment, and then we can pretend to scan this. So in that situation, if I go ahead and jump into my alignment tool now, because we have some GD&T measurements, we've got datums to work with. Typically, we can actually align to those datums using a datum reference frame alignment. So we can actually use this tool here to perform a datum reference frame alignment. And since I've just set up those a positional control to datums A, B, and C, that automatically creates a datum reference frame to datum A, B, and C, which I can go ahead and align to here. If I hadn't done that prior to this, I could always create my own datum reference frame from the drop-down lists here as well. In this case, align to A, B, and C. Now, obviously, that doesn't really change anything here because we're making up data and it's already on the CAD. But obviously, it won't look like that when you actually measure it for real. So in this case, you can see we do have our alignment taking place on the left-hand side as our DRF ABC alignment. Next up, we need to do some scanning in order for us to measure the remaining measurements. So let's go ahead and connect to our scanner. So disconnect from my probe. We're connect to the scanner. Let's connect to a different device this time so we can be fair with our vendors. So let's connect to a Hexagon device, for example, and jump into our scanner. Again, no error messages or anything, because even though we don't have one physically connected to my laptop, it can still jump into the scanner tool and pretend to scan with it. So we can name the scan whatever you like. We'll generate just a normal service scan, use the real-time quality mesh. Obviously, even though we are pretending to connect to the device, there's still kind of limitations. We can't actually access, for example, the RDS software because we don't actually have the actual hardware connected. But let's go ahead and start scan. And you can see in here, it does generate lines of points like a laser line scanner would. And this does actually work based upon line of sight, like a real scanner would. So if there's areas of the part that you can't physically see to scan, PolyWorks won't be able to scan the area as well. So if I show you the inside there, you can see you can only scan so far into that hole, much like a real scanner would. The exception to the rule is it will scan around the entire model. It doesn't actually know how this is sat on the table. Chances are this will be probably sat on this face here, and you can see there's scan data there as well. So just keep that in mind. You'll also notice that the scan itself looks a bit blocky compared to how you normally see your scans, and that's mainly because because this is made up data, it doesn't actually need as much detail. So rather than wasting time for it to calculate and mesh lots of small triangles, it actually does a rough scan, leaving you kind of bigger gaps between points, which obviously ends up with bigger triangles around corners and edges. But again, that doesn't really matter because this is made up data anyway. So let's bring those back. So with that data there, we can actually start to extract our measurements. We can highlight the remainder of our features, right click and say extract measured, and they'll simply go through and extract all those. Now you notice these numbers here aren't perfect. Even though we're generating the scan based upon the CAD model, we should in theory have perfect numbers, but we don't in this case. Two reasons for that. One, I've already mentioned, due to the resolution of the scan. We've got kind of blocky edges. PolyWorks is still using that data to extract from, and since it's not detailed scans, it's quite a rough scan. It could affect our results, which is what it's doing here. And secondly, PolyWorks has also included a random noise generator into the scanner. I'm assuming mainly just to kind of make it look a little bit more realistic in terms of if you generate real scans, you won't always have perfect scans. So to help kind of compensate for any errors, they've added a bit of noise in there just to make it look a little more realistic. But you can still obviously tell that it's made up data. So as long as your features are measuring correctly, there's no major issues. I could always right click on one of my circles and select the measure data points. And you can see all the points it's used to extract this circle from. I can do the same again, so right click, select measure data points of local plane to show me the constraint plane on top as well. If I'm happy with that, brilliant. I don't need to tweak and change that. But if you wanted to maybe consider more data, or if it's not extracting properly, then you would just simply right click and jump into your properties and just fine-tune the extraction parameters. But in this case, they should be good. The same applies to my comparison points. I'm going to right click on those and say extract or measured. So all those are now measuring. And same again for my calipers. I'm going to right click and say extract or measured, and extract all my calipers there as well. Okay, so with the offline simulation mode, we've now generated data. We've extracted our measurements. We've applied our alignment. We can even go as far as now applying a color map. All those are fine. Okay, obviously the color map doesn't look brilliant, but it's obviously made up data, so it's not going to be true to the part, but it'll apply it to the new scan when ready. So that's pretty much the full inspection. The only thing left now is to finish off by creating a report, which I'll quickly do. I'll just take a couple of snapshots and tables to finalize the process. So I'm going to start off by maybe showing just the scan, show just our datums, and report that information on its own. So spread things out, make it look pretty, and then I'm going to create a snapshot, create a control view from the objects in the 3D scene, which will instantly produce me a snapshot and table straight away. So these are my datums. Okay, and if I go into my report pages, you can see I've got my snapshot table straight in there. Let's go ahead and report our remaining circles. Create another snapshot and table. Hide those. Bring back my cylinders. Create a snapshot and table of my cylinders. Obviously I can do my distances and angles and everything else if necessary. So front view there between my two circles. Again, just call it a front dimension. Do my side dimension. And one at the back as well. Again, just speeding through this a little bit. And obviously I can do the same for my comparison points. And in this example, I'll just get PolyWorks to spread them out. And again, create both a snapshot and table at the same time. So comp points. And even for my calipers as well. Let's do that view there. Calipers. Okay, so everything is now reported. Snapshots, tables for each of those areas. And if I want, I can even finish off by adding my front page of the CAD model. So let's hide everything out of the way, turn the color map off, bring back the CAD, hide the scan, and we'll take a snapshot of that on its own. Capture. And also I can fill in the headers, the footers, watermarks and all that stuff as well. And then obviously that will be ready to export as a PDF. And that is a complete inspection. This is now ready to be saved and potentially sent off to the guys on the shop floor to start inspecting, or for me to just pick up the laptop, go down to the shop floor myself and actually start measuring once the part is ready, once the hardware is set up. The only thing you do need to make sure you do is obviously we'll save this. So cylinder part. And what I'll do is make sure that I turn off the offline simulation mode. If I don't disable that, as soon as I run the new piece to measure the next part, it would run through the simulation all over again and create new made up data again, which you don't want. So make sure you do remember to turn that off. When you're ready, you would then simply hit new piece, and it will then run through the process. Ask you to start by probing your first 3 features to measure your datums, and then it'll ask you to start scanning and so forth. Obviously in this case this will error out because we don't actually have a firearm connected. Okay. So that is how we create a full inspection program offline. When you don't have the actual hardware connected, you don't have the part available, you can still create a full inspection program with everything in there, from your color maps to alignments to reports, ready for yourself or anyone else to run the inspection program. That is pretty much it for this demonstration. Obviously, I'll check if we got any Q&As. Doesn't look like we have any questions, but obviously, if you can't think of any questions now, but you come up with a question later on, feel free to get in contact with us. With obviously the situations we're all in, whether we're working from home or in the office, please stay safe. But we're still working vigilantly. So if you've got any questions, any problems, do get in contact with us either via telephone or email, support@3dscanners.co.uk. We're still offering consulting training. If you need any further assistance on that, please do let us know. Otherwise, stay in touch. We will be hosting more of these PolyWorks webinars in the future with a variety of different topics to discuss. So I think that's pretty much it. Thanks again for attending, and have a wonderful rest of the weekend. Well, rest of the week for you. Thank you.